Prior to graphing linear equations, such as this one, I'll need to take a moment to talk about the rectangular coordinate system. Sometimes this is also called the Cartesian coordinate system. In honor of René Descartes, a French philosopher, mathematician, and scientist, who was a young man in the early 1600s. He is credited with inventing this two-dimensional grid, where you can represent any point in two-dimensional space with simply two numbers. He also realized that you could represent the solutions to algebraic equations on this grid. This served as a foundation for not only calculus, but many other areas of mathematics and physics. I'll identify the axes. So with a coordinate grid, you have both an x-axis, it's horizontal, and a y-axis, it's vertical. To help you keep this straight, you might think y goes to the sky, so y is the vertical axis. The x-axis is similar to the number line. I haven't written a 0, I'll put that in shortly. Negative values go off to the left, they continue forever. We don't usually put an arrow on a coordinate grid where the numbers are decreasing. We put an arrow where the numbers are increasing. With the y-axis, again, negative numbers go down, but we don't usually put an arrow down here. Positive numbers go up. These values are increasing, and that's the side where we put the arrow. Now I'll identify the quadrants. The first quadrant is the upper right-hand one. Typically, Roman numerals are used to identify a quadrant. Then you proceed counterclockwise to the second quadrant, to the third quadrant, and finally to the fourth quadrant. The origin we identify with the point 0, 0, is where the two axes cross. So I'll put the ordered pair 0, 0, and I'll write the word origin. Now I'll graph these ordered pairs. They're called ordered pairs because they're always given in the same order. The first number is your x coordinate, and the second number is your y coordinate. So the ordered pair 3, 2, starting from the origin, for the x value you go over 3, and for the y value you move up 2. This is where you put the point. So that's the point 3, 2. For -1, 4, for the x value you move over -1, and then for the y value you move up 4. We put a dot right there. If you think you have the hang of this, if you want to pause the video and try these, that would be fine. -5, -2, starting from the origin. For the x values, you move -5. For the y values, you move -2. You put your dot here. For 1, -3, you move over 1 and down 3. For 0, 3, you don't go left or right at all. You stay at the origin for the x value, but then for the y value, you move up 3. For 4, 0, for the x value, you move over 4, but for the y value, you do not move up or down. Because it's a 0, you stay on the x-axis. You put your dot there. You could be asked what quadrant a point such as 3, 2 or -5, -2 falls in. Obviously, 3, 2 would be in the first quadrant. -5, -2 would be in the third quadrant. But if they ask you about a point that's on the axis, it is not in any quadrant, it is on the axis. So 0, 3 is on the y-axis, 4, 0 is on the x-axis. You could be given a point and asked to identify it. So for instance, you could pause the video, see if you can identify this point. It's -4, 2. If I put a point down here, this point is for the x value over -2. For the y value, it's down -2. So it's the point -2, -2. And if you're given a point way down here, for the x value, you did not move left or right. So the x value is 0. The y value is down -5.
Notice that there are two different variables. So what the equation actually represents is a relationship between x and y. Unlike previous equations where you had all x's or all y's and one correct solution, now equations with two different variables are going to have many solutions. We'll use an xy table to just find a few solutions.
Notice if y is 0, this will be pretty easy to solve for x. So we'll try y is 0. And we'll find out what x is. Start with your original equation. Put in a 0 for y. I could use parentheses here, but I'll just put a dot, 2 times 0. Obviously 2 times 0 is 0, so we have 3x equals 12, and just get rid of the 3. So you're left with x equals 4. So when y is 0, x is 4. This gives us an ordered pair, 4, 0. So to plot that point, over 4, but you don't go up or down. The solutions to this equation are represented with a line. I can't make a line with just one point if I don't know anything else. So we'll go ahead and find another point. Notice if x is 0, this will be easy to solve. So when x is 0, let's see what y is. Start with your original equation. Plug in a 0 for x, and bring everything else down. Obviously this is 0. We have 2y equals 12. And let's get rid of the 2. So you're left with y is equal to 6. So we put the 6 in our chart. And now this gives us the ordered pair 0, 6. So no back and forth, but you go up 6 and put a dot. Now with 2 points, I could draw a line. But it's a good idea to pick a third value and find a third point, just to be sure everything lines up. So if I say x is 2, it looks like this equation will solve pretty easily. So with x being 2, we'll see what y is. This gives us 6. Let's get rid of the 6 first, and then get rid of this 2. I'm sort of running out of room here, but we're left with y equals 3. So we'll put in a 3 in the y column, and this gives us another ordered pair, 2, 3. So you come over 2 and up 3. Put your dot. We simply draw a line to represent all the solutions to the equation. And I put an arrow at each end because this line continues forever in each direction. It's critically important to understand that this line represents every solution that there is to this equation. I'll give you two examples. Notice that the point right here is clearly 6, -3. I found this point graphically, that is by looking at the graph and identifying a clear point on the line. I can also check this value algebraically. I'll start with our original equation. I'll just do some scratch work down here. We know this to be a true statement, but if we plug in a 6 for x and a -3 for y, here I'll use parentheses since I have a negative value, is this equal to 12? I want to emphasize I don't know that it's equal at this point, so I'll put a question mark over the equal sign. So what do we have? 18 minus 6, is this equal to 12? 18 minus 6 is 12, which is certainly equal to 12. And with that true statement, we've shown that 6, -3 is a solution. If I pick a point that's not on the line, let's say 2, 1, and I plug it into our original equation, what's going to happen? So I start with the original equation. I plug in a 2 for x, a 1 for y. Is this equal to 12? 6 plus 2, is that equal to 12? So I end up with the statement 8 equals 12, which is not true. So this shows that 2, 1 is not a solution. Quick review. You can find a solution graphically by looking at the line that represents the equation. If you can identify a distinct point, 6, -3. You can check this point algebraically by plugging it into the equation. If you end up with a true statement, then the point that you plugged in is a solution to the equation. If you take a point such as 2, 1 in this case, plug it into our original equation, you end up with a statement that's not true, so you've shown algebraically that 2, 1 is not a solution to the original equation. You can also say that graphically because it's not on the line. All right, we're asked to create an XY table of solutions and graph the equation. So for this equation, I'll put my XY table down here. So first I'll plug in a 0 for y and see what x is. So we take our original equation, plug in a 0 for y. I'm just going to use a dot for the multiplication. Obviously, -4 times 0 is 0, so we're left with 2x equals 20. Let's get rid of the 2. And we're left with x equals 10. So I put the 10 in the xy table. So this gives us the ordered pair 10, 0. When x is 10, well, I should say when y is 0, x is 10. Even though I could say it either way. But I started saying y is 0 Let's see what x is. Now when x is 0, we'll see what y is. Obviously that's 0, so we have negative 4y equals 20. Let's get rid of that negative 4. And we're left with y is equal to negative 5. Put that in the chart. So now we have two ordered pairs. We have 10 comma 0. That's over 10 but no up or down. Put a dot right there. So 0, negative 5, that's an ordered pair. 0 comma negative 5. I've graphed it right here. No back and forth, just down negative 5. With these 2 points, I could just draw the line and I'll have all the solutions to the equation. I think I'll do that, and then I'll just find one more point to ensure that my line is correct. Now looking at the original equation, I could pick any value for y and find x, any value for x and find y. But I want to find a value that's on the graph, even though the graph continues forever in all directions. But I want to make it easy to see that I'm correct. I think I'll just pick x. I'm going to say it's a 6, because I think the algebra will work out pretty nicely. So when x is 6, let's see what y is. This gives us 12. Let's get rid of the 12. Let's get rid of the negative 4. And I've sort of run out of room, but I think you can see y is equal to a negative 2. So I put a negative 2 on the chart, and this gives us the ordered pair 6, negative 2. So over 6, down 2, and we land right on the line, so we can be confident that these were correct as well. There's a concept that's important to get across here. Notice that this line in effect crosses the y-axis and crosses the x-axis. We refer to this point as the x-intercept. We refer to this point as the y-intercept. You'll often be asked to find intercepts and or to graph using the x and y intercepts. So in this case, we're asked to create an xy table of solutions including x and y intercepts. So they're asking specifically for the intercepts, and we will graph the equation. So for the x-intercept, y is 0. We'll have to find out what x is. Solving for x, so we have to get rid of this negative 6. Get rid of the 2. And we're left with x equals 3. So we put that on our chart. This gives us the x-intercept, 3 comma 0. Now we'll find the y-intercept when x is 0. Obviously that's 0, so we're left with y equals negative 6. Put that in the chart. So with these two ordered pairs, we could graph the equation. Now I could have made some algebraic mistake in finding either of these 2 points, so I'm going to pick one more value and make sure it lands on this line. If you notice, if we pick a value for y, it's a little bit more work. If we pick a value for x, The equation is already solved for y, so life's pretty easy. So let's pick a small number for x. Let's say when x is 1, what's y going to be? So that clearly is 2. So we have y is equal to negative 4. Put that on the chart. And let's hope the ordered pair 1, negative 4 lands on the line. Over 1, down 4. There we go. We're to create an xy table of solutions, including the x and y intercepts, and then graph the equation. So first our xy table. And now when y is 0, we'll see what x is. Solving for x, obviously that's just 0, so we have x is 0. We'll put that in the chart. Now when y is 0, we find out that x is 0. It follows to reason when x is 0, y is going to be 0. I'll go ahead and show that this time, but it's really an unnecessary step. So when x is 0, we'll find out what y is. And we have y is equal to 0. So the x-intercept is 0, 0. The y-intercept is 0, 0. We've really only found one point. So I'll pick an x value. Let's say x is 1, and we'll see what y is. And we have y is equal to 5. Negative divided by negative gives us our positive 5. Put that in our chart. So I'm going to pick one more value and find a point. So when x was 1, that worked out pretty well. Let's try x is negative 1. I have to move this up a little because I'll run out of room. Notice this time I used parentheses because I plugged in a negative value. You could indicate multiplication with a dot, but I just like to be more careful using parentheses. So this gives us negative 5. So we have y is equal to a negative 5. We'll graph our three ordered pairs. First 0, 0, 1, 5 over 1, up 5, negative 1, negative 5, back 1, down 5. Now we can draw the line. So we have all the solutions to our original equation. Notice it does go through the origin. So the x-intercept is 0, 0, and the y-intercept is 0, 0. If you would like some practice with these concepts, as long as you're at my website, I have a worksheet along with a detailed answer key. It might look like a lot. It's only 16 questions. It's just that graphs take up a lot of room, so they'll be usually 2 graphs per page.